This video simulates the RAM memory working. It is the simulation part of the third video of the How Computers Work Build Scott CPU YouTube playlist. We use the Circuit Valve Simulator, and the circuit is available in the link I leave in the description. Here you see the enabler. It is an element used to control an input byte or to block a byte. It is composed by 8 AND gates with one of the inputs connected altogether with this enabler bit. When this bit is 0, one of the inputs of the AND gate of each of the AND gate is 0, so the output is 0 because the AND gate needs both the input to 1 to have a 1 on the output. So putting one of the inputs at 0 will block the byte. We see the input byte cannot pass through and go to the output. The input byte cannot go further, but when the enabler is at 1, we see the input byte goes to the output. So this is the enabler bit which control the input byte, and it allows it to pass through the output or not. This is another kind of enabler. It is called three-state enabler because when the enabler bit is at 1, we let pass the input bytes. Here you can see the byte passes unchanged through the output, but when the enabler bit is at 0, we block the byte, not imposing a 0 as we saw before, but showing a high impedance, because the high impedance allows us to share the bus with many different kind of registers and elements, because with high impedance we do not impose any kind of byte or bit, any kinds of logic value to the bus. In this way, the bus can be used to add a register. All the register or element not using the bus has to show a high impedance in order to free the bus, because imposing a 0 can create conflict on the bus if another register are putting its byte.
So here a 8-bit register. You see it is composed by an 8-bit memory cell plus an 8-bit enabler with 3 state. It has a byte as input, it has a set input and an enable input, and the output of course is a byte as output. So let's see how it works. For example, we want to acquire a new byte, is the number 1. I put the least significant bit with at 1, and we see in light green the line at 1, and in dark green the line at 0. As you see, the output bit remains at the previous value because the set input is at 0. If we want to acquire this new byte, we have to put the set input at 1, and as you see at the output of the 8 memory cell there is the new byte. Now I can put the set to 0, the memory cell holds the previous value, but we don't have at the output this byte because the enabler bit is at 0. If we put the enabler bit at 1, we put the byte to the output and probably to a bus. So we occupy a bus with this register, posing to the line of the bus this new value. If we want to free the bus, we put the enabler to 0. Now we see how to move a byte from a register to another using a bus. So here is a 3-state connecting with the bus, and connected to the bus we have 2 registers R1 and R2. This 3-state is just used to put this byte in the bus. So now we want to put a byte in the register R1 and later move this byte from R1 to R2. So let's see how to do this. First of all, we want to put the byte 1. So all the most significant bits are at 0 and the least significant bit is at 1. So I put enable to 1, so I put this value on the bus. So the value here is 1 is on the bus. In order to acquire this value in the register R1, I have to put the set to 1. And then I put this set to 0, so now this byte is acquired in R1. To check this, we free the bus, and we can check the value clicking to this enabler of the register 1. I put this enabler to 1, and I see the bus shows the value 1. So we have acquired correctly the byte in the register 1. Now let's see what there is in the register R2. So we put the enabler to 1. We see in R2 there is the byte 0. So all the lines are at 0. Now we want to move the byte in R1 to R2. So in order to do this, we put first the byte on the bus, and second, we acquire with the set input of the register 2 the byte in R2. So in this way, we have acquired the byte in R2. We put the set to 0, we put the enabler of the R1 to 0, and now putting the byte of R2 in the bus, we are able to see what kind of bit there is in R2. And there is the byte 1, not the 0 anymore, because we have moved the byte from R1 to R2. Here we see a 8-bit register with the logic we need in order to choose the right register in the RAM memory. You have to think the RAM memory is composed by the millions of these registers organized in row and column, and in order to choose the right one, we need this logic. This vertical and horizontal line are coming from two decoder. The decoders are driven by the memory address, and the decoder let activate one line each. So we are going to select the register at the intersection of these two lines. So one vertical lines and one horizontal lines. In order to activate the register, we need both the vertical and horizontal line at 1. If at least one of the two is at 0, or both are at 0, we don't activate this register, because you see, if we change the set or the enabler bits, nothing happens, because these two ends are blocked by the 0 of this end 1, because if at least one of the inputs of end 1 is at 0, the output is at 0, and the output of end 1 at 0 blocks end 2 and end 3. But if both vertical and horizontal lines are at 1, we can write and read the register. We write with the set bit. In this way, we acquire the bit in input. If we give a set pulse, we acquire this input bit, for example, this 3. So we are writing in the register with the set pulse. And in order to read, we have to give an enable pulse in this way, and we read the byte written before, so the 3, the value 3. But this is possible just when vertical and horizontal lines are both at 1. Here we have a 4 bits RAM memory. Here the 4 registers. Here the 2 decoders to be able to select the right register. We have a 328 decoder, but we just use 2 lines per decoder. Here there is the bus, and we can put a byte in a bus with this enabler. So we are going to put to write a cell and to read from it. So we start putting, for example, the number 3. we put the number 3 on the bus. We select, for example, in this way we have selected the cell 1, because you see is activated both the vertical and the horizontal line of the cell 1. So we have selected this register. So we write this value on this first register. So we give a set pulse, and we free the bus in this way. So now the bus is free. We want to see if we have written the number 3 in this first register. So we leave the decoder with this selection. So we select always the first register in this way, putting 00 and 00 in this other decoder, and we read the register. So the register where the cell 1 put the byte on the buses, and we are going to read the bus, and you see there is the number 3. So now we switch off this enable, and we free the bus again. We want to put the number 1, for example, in the cell 2. So we are going to select the cell 2. In this way, you see vertical and horizontal line of the cell 2 are selected. So we are going to put a number, for example, 0. No, the number 4. So we put the number 4 on the buses. We have already selected the cell 2, so we give a set pulse. So we are acquiring now in the cell 2 the number 4, and now we free the bus. So now the number 4 is written in this cell, the cell number 2. No, sorry, the cell number 3. So we are going to read the cell number 3 now, giving an enable pulse, because this cell is already selected. So we give an enable pulse, and the cell number 3 put the byte, its byte in the bus, and we read the byte in the bus, which is the number 4.
Please leave me a comment, let me know if you liked this video, make sure you put a thumb up, click the notification bell and subscribe to my channel.